Okay, this is a part 2 of the video I made about the measuring a ball, measuring the different drop angles on different parts of a ball. I had some people that just couldn't get it, so I just figured I'd try to make this a little bit more clear. I rigged up this little wire on my phone, I wrapped it around my phone, then put a stick on it, painted the stick, marked it with a Sharpie, and I'm going to move it on different parts of this ball and show you that there are different, there would be different drop angles on a ball. You can measure a ball from anywhere. Now this is a little beach ball I've got. It's got the little ridges, little beach ball painted like the moon. I'm going to set my phone on the ridge, and I'll put a little picture-in-picture here and see what my phone camera sees. So I'll touch the stick to the ball, and you can see the bottom black line there. See just a little bit of it. Now when I move my camera and move my phone up the ball to a smaller portion of the ball, you see less of the little black line will disappear. You see less of the stick. Okay, back to the middle. You can see the top of that bottom black line. Now you can do this yourself. I move to a different part of the ball. The stick, you see way less of the stick. Okay, this is a smaller part of the ball. So I will pull up a little graphic here in just a minute and show kind of a little bit more, a little better. I mean, I thought I did a pretty good job with the foam balls, kind of explaining this, but few people didn't get it. But so I was back and forth in the comments, and it inspired some thought. So I'm glad for the. I'm actually happy to get a little feedback, and it got the wheels turning and made me think of this. Hope you can kind of see now what I'm talking about, but try this for yourself. You could do this with a string or whatever. People had me doubting my premise, but I think this proves what I was trying to say. Back to a ball has a fat part and a skinny part. I mean, so to speak. Just like if you were to palm a basketball, your hand is not going around the entire circumference of the ball. It's going around a smaller part of the ball. I mean, I know this doesn't make, it's kind of hard to visualize, but you can see this. You can see more or less of this stick on different parts of the ball. I said I encourage anybody to, simple, just stuff I had laying around the house. You can try this for yourself and see what I'm talking about. And then back to a smaller part of the ball. Stick is almost, definitely see, you can see more and less of the stick on different parts of the ball. Alright, hope that's a little more clear than the foam balls I was using. This is going to be like a follow-up to my 8 inches per mile squared video. This is only for the people who didn't get it. A lot of people get exactly what I'm talking about. Some people are having trouble visualizing this, I guess. But you can measure a ball at different points on the ball. Okay, spherical segment. This, you measure a circle around this part of the ball, it's going to be different than the full circumference of the ball. I mean, you can measure a segment up here. This is, a ball doesn't have to be measured at the full circumference. As you move up on a ball, it gets smaller. I mean, this is pretty pretty simple. But you know, everybody keeps saying, well, no matter where you're at on the ball, you'd be on the top. Well, no, you wouldn't if you were like on the Earth. They tell us the Earth has gravity and it's a spinning ball. So if you were standing somewhere else on the Earth looking this way, if you were standing right here on this line looking, say this is east and west, this would be a smaller portion of the ball. I mean, this is not the best I can explain it. I thought I did a decent job with the foam balls, and I said a lot of people got it right away. Some people it's not clicking for, but I'm not gonna, I'm no math genius, but you can go in here. I'll leave a link to this. You can go in here and play around with this and see how the stuff would be different. But pull up on Google Earth here again. Okay, back on Google Earth again. If you were on the Arctic Circle looking this way, you'd be looking along that smaller part of the ball. And people keep saying that no, it'd be the same, but it wouldn't. It would not be the same measurement. And they keep saying, well, the line would be curved. But if you were down here standing on the Arctic Circle, you would not know that line is curved. Let's do a little measure tool here. Say if you just wanted to measure. So if you were doing say a 20-mile observation, would you know that line was curving? No, you wouldn't. You would be looking east along this line, and you wouldn't know it's curving. There's 28 miles. Well, there's over 50 miles. You can start to see the line deviate just a tiny bit, but the Arctic Circle is 9,900 miles long. If this were a road and you drove that road all the way around it, you wouldn't have no idea you were turning. It'd be so gradual you wouldn't even know it. But the curve drop would be different. And okay, and just to reiterate this again, they say that the Earth is moving at 1,037 miles per hour at the equator, and the further you get away from the equator, the slower your speed would be. The reason for this is because you're on a smaller part of the ball. I hope this makes sense. Makes perfect sense to me. It makes a lot of sense to a lot of people, but for people to get in the comments and tell me I'm making flat earthers look bad because this is ridiculous, it's not ridiculous. Just because you don't see it the way I do, it doesn't mean it's ridiculous. This is what the heliocentric model teaches, and if you learn what the heliocentric model teaches, it's easier to debunk it. Because we know this is not true, but if you were on a smaller part of the ball, the curvature would be more, period. Really hope this makes sense. I'm not going to keep, I appreciate all the comments. I said it makes me think a little bit. And I was kind of doubting myself there for a minute, but I knew I knew how I was seeing it, and my little experiment with the beach ball proves it, I believe. I said, hopefully this makes more sense now. But anyway, thanks for watching. All right, that's all I got for this one. Hope this clears things up just a little bit. I said, thanks again for watching. Appreciate all the comments. Hopefully this inspires some thought. All right, let me know what you think about this. Later.